Hey guys, so welcome back to part 2 of complex numbers, and today I wanted to do a separate video on division of complex numbers because there's a little part called complex conjugates that I wanted to introduce to you guys before we get into division, because trust me, there is a purpose here, okay? So you guys from previously part 1 of complex numbers would have understood what a complex number actually is. It has a real and imaginary part, and it has that letter I in it. Now a complex conjugate is simply a pair of complex numbers that always happen next to each other, okay, side by side. And let me give you some examples of what they look like. Let's just say we had, let me change the color. Let's just say we had a complex number 2 plus 4i. Okay, the complex conjugate to this complex number is denoted by a bar on top, or it could also be represented by an asterisk placed at the top right hand corner, okay? And how do we form complex conjugates? We simply consider the sign that's in the middle, the sign that connects or lies between the real and that imaginary part, and we simply change the sign. So if it was a plus, we change it to a minus, and then we continue rewriting the real and imaginary parts just as they always were. Okay, this would be the same thing, right? So if a student chooses to write the complex conjugate of z in this format, that's fine. And if they choose to write it having the asterisk, that's also fine. Let me just do one more quick example just so you guys are 100% sure about it, okay? Let's just say we had something like c is equal to -5 minus 6xi. Is it a complex number? Yes, it is, because it has what? It definitely has a real number here, a real part. Of course, 6x is also real, but because of the presence of this I, that makes this term imaginary. So that's the imaginary part. So it is a complex number, check. Now, if they ask you to write the complex conjugate or the corresponding pair to this complex number, you can choose your denotation. I'll use the bar, and the answer will be, remember, the only thing you need to do is change the sign in the middle. So this blue sign here, the minus changes to a plus, and everything else comes down unaltered. Okay, a lot of students, this is where the mistake happens. Let me just highlight this. You see right here, a lot of students attempted to change that sign. That sign is just simply the sign in front of your real part of your complex number. A complex conjugate happens when only the sign in the middle between the real and imaginary part gets changed, okay? So just take note of that in the future, and I hope you guys do not make any mistakes. Ooh, there's a lot of doggies outside. Okay, so in light of what I just told you guys, a complex conjugate is all about, it's just a pair, and they're related by a change in the sign in the middle. What if they gave you a complex number z here? Okay, so this is a complex number, z, and they're saying that z is equal to 3 plus 2i. And then the question is telling you to multiply z by its complex conjugate, denoted by that asterisk at the top right hand corner there. How do you find that? Well, firstly, what you need to do is you need to find out what z asterisk or its conjugate would be. And that would simply be 3 minus 2i. So now that we actually have what both complex numbers look like, let's see what multiplication will do. So z is 3 plus 2i, and z asterisk is 3 minus 2i. Now it looks like a typical FOIL method expansion of brackets. So let's just go ahead and let's just do this. Okay, I'm going to just scooch. Okay, there we go. I'm going to change color here. Things starting to get boring in black. Okay, so here we go. 3 by 3, that's 9. 3 by minus 2i, that's minus 6i. Same thing down here, that's plus 6i. And then finally, 2 by negative 2, that's negative 4i squared. Okay, and if you guys can remember, I squared is equal to negative 1. So let's clean up this. 9 minus I plus 6i will cancel each other out. And this I squared becomes minus 1. If this becomes minus 1, then minus 1 by minus 4 gives us plus 4. And this just gives us a value of 13. Okay? Now, I want you guys to actually see something here. I think I may have to do another example to show you. But remember our initial complex number? Remember our initial complex number just for a millisecond, and I'm going to show you guys something on this side. So our initial complex number z was equal to 3 plus 2i. And if you observe the real and the imaginary values, if we were to square those, 3 squared, 2 squared, and add them up, guess what happens? You're going to get 3 squared is 9, 2 squared is 4, 9 plus 4 gives us 13. Oh, I know. Now, that could be a coinkydink, or it could actually be a rule. Let's try another example and see what happens. Okay, so let's just say this is example 2, and we have a complex number z equal to, let's make it simple, 1 minus I, such that z asterisk, so z bar, if you want to call it, we'll switch it up, plus I is the complex conjugate or pair with z. And they want us to multiply the complex number with its conjugate. Let's see what happens. You will have 1 minus I multiplied by 1 plus I. We're going to perform some basic FOIL method expansion here. 1 by 1 gives you 1 squared, which is just 1. 1 by I gives you plus I. On the bottom, you will get minus I. Then finally, minus I by I gives you minus I squared. Remember, I squared is negative 1. So we are going to do some simplification here. 1, these two will cancel each other out. Plus I minus I cancels to 0. And then here, because I squared is equal to negative 1, you will get negative 1, which is plus 1. And that gives us a value of 2. Now let's do that thingy that we did over here, where we take the complex number, we square both the real and the imaginary parts, and we find the sum. Let's just see what happens here. So our complex number is 1 minus I. Our real part squared is 1 squared. Our imaginary part is actually still, well, negative 1 squared is still going to be 1 squared. And that's 1 plus 1, which gives you 2. What do you guys notice? So it is a pattern. And guys, guess what? It's actually a rule. So generally, the rule goes like this. Okay, I'll write it to the side. And anytime you actually forget this rule, you can test it by doing this full method. So if you blank out during exams and you cannot remember, do I add the real and imaginary parts? Do I need to square them? Go ahead and try the long way and see, and you'll figure it out. Okay, so the rule goes like this. If you have a general complex number in the form a plus ib, then the product of the number with its complex conjugate is simply equal to the sum of the real part squared and the imaginary part squared. Now, why did I even tell you about these things? Because remember we didn't do division of complex numbers last class? Well, guess what? Complex conjugates play a huge role when it comes to division of complex numbers. And you will see that up next. Okay guys, so we're back. And I just want to say something. I don't know what you guys can hear in the background, but I honestly feel like my house is a zoo right now. I mean, there were dogs barking just outside my front door in the road, and now I think I'm hearing like a frog in the back. It's been raining a lot, so I guess they're out, but honestly, the sounds, I'm not sure what you guys can hear, but I'm just like giving you guys a heads up. If you hear a little ribbit and a roof, that's what's going on. Okay? Okay, so on to division of complex numbers. So let's just get straight into it. Now, for division, there are rules you can have, like, you'll see frequently in some textbooks, they'll show you, like, if you have two different numbers, of course, recognized by z subscript 1, z subscript 2, because if you use z, it means it's the same complex number. You must have some sort of way to differentiate complex numbers, right? But if you were to divide two complex numbers and you wanted to give like a rule for it, then you can call one of them like a plus bi, and you can call the other one like c plus di, and you can give a general rule and you'll see it happening. The general rule of division says that in order to like divide two complex numbers, you must multiply by whatever is on the denominator, you must multiply by the complex conjugate of it. So since the denominator is c plus di, the complex conjugate of that would be c subtract di. And because we cannot affect or alter a question, we will also place that same thing on a denominator. So in essence, they actually cancel each other out and they do not affect the division of the question in any way. And some of you guys might relate this, doing this over here, to a topic called surds. If you guys remember in surds, if you have something like 3 over root 2 and you wanted to rationalize that denominator, what? Yes, rationalize. For those of you who forgot, rationalizing a denominator means trying to get rid of that square root or surd on the bottom. Okay, so to get rid of it, you would have to like multiply like this same kind of method they would use to eliminate the denominator from being a square root. And then you would have gotten something like 3 root 2 over 2. And they call this process rationalization, okay, of the denominator. So when it comes to division of complex numbers that are totally different from each other, then it's kind of like a similar process if you think about it, okay? So you just have to observe what's on your denominator, and in this instance, you would multiply by the complex conjugate top and bottom. So that's what the rule looks like for those of you guys who really love to memorize rules and stuff like that. But honestly, if you had to memorize all the rules in the world for math, I think your brain would be fully loaded. You would be like rich, you know, fully loaded. But it's always best to understand the concept behind it. So instead, what I'm going to do to sing this division process in your minds is to actually give you an example. All right? So let's just consider a case in point where we had a complex number z1 being equal to, I'm actually going to use an example from a textbook here. Okay? And we're going to divide it by z2 that has a value of 1 minus, okay, fine, I'm not going to use a textbook, I changed my mind. 1 minus 3i. We're going to switch it up, okay? Then how do we work something out like this. Z1 is 2 plus 4i, and Z2 is equal to 1 minus 3i. Well, according to the rule, you got to multiply, observe your denominator, and multiply top and bottom by its complex conjugate. Recalling what a conjugate is, you just need to change the sign in the middle, and that's about it. I'm going to minimize this so we can probably go straight across instead of like top and bottom, okay? So let's draw some huge division signs here, and let's go ahead and observe this and this. Now, essentially, 1 minus 3i is Z2, but what do you notice? 1 plus 3i is actually the complex conjugate of 1 minus 3i. And remember, we just did that rule that says whenever you're multiplying a complex number by its conjugate, all you have to do is take the first real part, in this case that's 1, square it, and add it to the imaginary part. In that case, it's 3 or negative 3, whichever one you want to use. So that's 3 squared, and boom, you're done. Now you know why we did what we did previously. It's to help you from having to expand a full FOIL method for the multiplication of these two complex numbers on the denominator. So things just got really, really nice and quick and easy. Unfortunately for the top though, we do have to perform that long expansion of brackets. So let's go. 2 multiplied by 1 gives us 2. 2 multiplied by positive 3i gives us plus 3 2s is 6i. Then 4i multiplied by 1 gives us plus 4i. And then finally, positive 4i multiplied by positive 3i gives us positive 4 3s are 12i squared. You're probably wondering what's the dot method? What's up with that? I have many different ways I expand brackets. I can draw lines, I can do it by sight, but a lot of times, even though I've had so many years experience, I've found that doing it by sight, I can now and then make mistakes, and I do not like to make mistakes in big questions that have like a part B and a part C that follows. So I use this dot method that tells me if there's 2 dots above each term in the bracket, it means that I multiplied correctly. Okay, it's just a thing. But whatever works for you is fine. Do what makes you feel comfortable, okay? So let's go ahead and clean up that numerator. So remember that I squared, this thingy-majig here, is -1. So we're going to go into play here. We're going to have this 2. Okay, let's just write everything out. 2 plus 6i plus 4i gives us 10i. And we're also going to get -12 because I squared gives us -1. And -1 multiplied by 12 gives us -12 on the top. That's good. On the bottom, we have 1 squared, which is 1, plus 3 squared, which is 9. So that's 9 plus 1 gives us 10. And then finalmente, we clean that top up to get -10 plus 10i. Hey, that's so cool. I actually made up this on the spot, guys. Live. Well, not live for you guys, but live for me. I was gonna take it from a textbook, but then I decided to change one number and it ended up working out nice. So we can actually just divide these. Yay. Okay, so that just gives us -1 plus I, and that's our final answer. Now, usually I want to say for division, you will usually get a denominator in most cases, and if you do, you would just separate both terms with whatever the numerator happens to be. But in this case in point, things worked out perfectly. And when you're dividing complex numbers, your aim is actually to get your final answer in the form of a complex number. It's going to have 2 parts. It's going to have a real part and an imaginary part. And in most cases, scenarios, you're going to have your real and imaginary parts being fractions as well. Okay, so that's it, guys. That's what I really wanted to show you guys. I hope that you were able to thoroughly understand division of complex numbers. Lastly, I'm going to show you guys a special case scenario because we've done all the 4 basic operations, but there's just one more thing I want to show you guys, and that's how to find the square root. If it pops up, how to find the square root of a complex number. So that's up next, and then I think that'll be the end of part 2 of our video. So stay tuned for more. Okay guys, welcome back, and thank you so much for staying tuned, okay? Remember, these videos are made for you to press pause and play whenever it's convenient to you at your own pace and at your own time. So do not feel overwhelmed. Sometimes if the work seems like it's too much, take a break, come back, okay? Life is meant to be lived. All right, so we're getting into how to find the square root of a complex number. Now remember, a complex number is something that looks like this. It has a letter Z and it has a format A plus BI. But I want to mention that when we're dealing with algebra, letters are just arbitrary. What do I mean by the word arbitrary? You can use any letter to represent it. So it doesn't have to be A plus BI. It could be X plus IY. It could be K plus LI. It could be any 2 letters could replace the X's and the Y's or the A's and the B's. Most importantly, the only stagnated thing that needs to be there is the I. Okay? So letters are just arbitrary, and sometimes I think students get thrown off when they see stuff they're not familiar with. So let's just say for exams, they ask you to express the square root of 3 plus 4i in the form k plus mi. I know a lot of people have been learning how to do it using these 2 formats, a plus bi and x plus iy. What happens if one day they suddenly say express it in the form k plus mi? What are you going to do? Well, you need to really take a breath, step back, and understand exactly what it is that you're doing. Okay? So here's how to attempt a question like this. First of all, if they're asking you to express one thing in a different form, it must mean that both are equivalent. So the first step you need to take is to equate both. So we're going to equate our complex number, the square root of, and we're going to equate it to whatever form they want us to put it in. If it's x plus iy, then we write it equal to x plus iy. If it's a plus bi, we write it as a plus bi. If it's k plus mi, we write it as they request. That's the first step. Now, your second step is simply to square both sides. And I think that's standard knowledge at this stage. If you're doing advanced maths, you guys should know to get rid of any square root, you simply square both sides. So squaring both sides will give us 3 plus 4i. So the square root sign just goes away. And if you were to square this, you would get x plus iy all squared. Now there's a shortcut to square this. If you know it, it's simply square the first term, square the last term, so you'll have y squared, I squared, and then you're going to multiply your 2 terms in the middle, not in the middle, sorry, you're going to multiply your 2 terms, x multiplied by iy, that gives us x, y, I, and you're also going to multiply that by the power 2. So that gives us a 2 in front. Okay, so that's a shortcut way of squaring any bracket that has 2 terms in it. If you didn't know it, now you do. Now we're going to clean this up because we remember anytime you see I squared, you got to remember, what is it equal to? That's correct. It's equal to -1. Okay, and we're seeing it popping up here. So that means this is going to change into a -1 and it's going to disappear. All right, so let's rewrite this. We're going to have x squared minus y squared, because that I squared is going to be eliminated. It's going to change into a -1. And then we're going to continue writing 2x, y, I. Okay, so let's remember what we had over on our left-hand side. Let's bring it down. We had 3 plus 4i is equal to x squared minus y squared plus 2xy. Now, at this stage, a lot of students tend to think, well, that's my final answer, where the real part is just x squared minus y squared, and the imaginary part is 2xy. But you see, the thing is, they told us that they wanted it represented in a particular format, right? The format they want it in has only 2 terms. And those terms should have values. X and y should be real numbers, not algebraic letters. So you see, unfortunately, there's a couple of steps left that we need to take. Now we need to consider this as being an equation that has a left-hand side and it has a right-hand side. An equation that is also equivalent. Whenever an equation is equivalent, it means that both sides are exactly equal to each other. So on the left-hand side, we have to be able to identify that we have a real part on the left. And also on the right-hand side, we have a real part. This is our real part here. So what we're going to do is we're going to do something called equating real and imaginary parts. So equating our real parts on the left, we're going to get 3 equals on the right x squared minus y squared. And we're going to call that equation 1 because we're going to create simultaneous equations here. And we're going to do the same thing for the imaginary part. So on the left-hand side, we're going to have the imaginary part being 4. And on the right-hand side, we're going to have that imaginary part being 2xy. We're going to call that equation 2. And we're going to simply solve this simultaneously. Now, you guys know how to solve stuff simultaneously. So I'm going to just talk my way through it very, very quickly. Okay, no rocket science here. I'm going to use equation 2. And I'm going to make, let's make x the subject of the formula here. Make x the subject of the formula, so therefore you will get x being equal to 4 all over 2y, which is equal to, well, you'll just get 2 on top, 2 on y, okay? And then we're going to substitute x being equal to 2 on y into the other equation, which is equation 1, okay? So that will give us equation 1 goes like this. Let's change color. 3 is equal to x squared. So x squared is now 2 on y squared minus y squared. Breathe. Breathe, people, breathe. Okay, let's go. Back to the algebra. Okay, so you're going to get 2 squared. A lot of people forget to square both numerator and denominator when they're doing these questions. Now, whenever you want to get rid of a denominator, all you have to do is multiply across by that existing denominator, which happens to be y squared. So multiplying every single term across by y squared, we will get 3y squared is equal to 4 minus y to the power of 4. When you multiply this component by y squared, they get canceled out. So that's what happened. That's why 4 is by itself there. Just letting you guys know for those of you who didn't see it. And then, of course, y squared by y squared gives us y to the power of 4. If you remember your rules of indices, if those rules are intact. And continuing here, we're going to rearrange this equation such that we have all the terms on our left-hand side. So we're going to have, I'm going to carry across my y4 to the left, leave my y squared there, and carry across my 4. And then what happens is we end up having something we cannot solve. So we're going to have to use a bit of a substitution to turn this into a quadratic. So we're going to let y squared be equal to x. No, let's not use x because we kind of have x already in the question. Let's let it be equal to a. So then if y squared is equal to a, then y fourth will be equal to a squared plus 3y squared is a minus 4 And this is highly solvable. Okay, let's see what we'll get here. You get A, you get -4 plus 1, and that implies that A either has a value of -1 or A has a value of 4. Now, let's go back to our substitution here. Remember that A is actually y squared. So in reality, it's actually not A that's equal to -1. It's actually y squared. So we have to do that change. So we have y squared is equal to -1. And then we have y squared is also equal to 4. If you cannot follow what I'm saying, remember over here, we made a substitution. So after we solve our quadratic, we have to go back and replace our letter A with what it was meant to be. Okay? So I'll shift to this side here. And try to explain something to you guys. Remember, essentially, complex numbers occur in this format, A plus BI. And yes, BI is the imaginary component of the complex number. However, the letters A and B actually are supposed to, in essence, be real numbers, meaning that they can be irrational numbers, they can be fractions, they can be negative numbers, you can have the value x in there. Whatever a real number looks like, that's what A and B is supposed to belong to, but they have to be real. And in this case scenario, they're asking us to express the complex number in the form x plus iy, which means that essentially they want to make sure that x, let me just highlight this here, they want to make sure that x and y belong to the set of real numbers, right? So they cannot have any i's in it. X cannot be 5i, y cannot be 2i. There should be no components of I in those letters. And when we go ahead and we solve over here, if y squared is -1, that must mean that y is the square root of -1. And we all know that I squared is -1. So therefore, I is the square root of -1, which is, that's a completely imaginary number. Okay, so since this number is imaginary, then by process of elimination, since y should be a real number, this value is actually null and void and cannot be accepted. Okay, so our only true value would be this one here, where y would be the square root of 4, and that takes two values. It can be positive or -2. So boom, we have found two values for y. And going back to where we had x, because remember we're doing simultaneous equations essentially, and over here you can see that x was equal to 2 on y. We have to go and now we have to find values for x as you would with any simultaneous equation. So using that, let's just head on down. What am I playing? Price is Right, head on down. X is equal to 2 on y. Let me just check. Oh, my memory. It's going quickly. Okay. Wow. I actually did forget. Okay. So if x is equal to 2 on y, then that would imply when y has a value of +2, it would mean that x is equal to 2 on 2, which is 1. And also, secondly, when y has a negative value, x would be equal to 2 on -2, which is equal to -1. So we have two values also for x. We have positive and -1. So at the end of the day, you have two solutions, all right? And our two solutions go as follows. Our first solution is that this square root, remember our original question. What was our original question? Can anybody remember? Oh, our original question was to find the square root of, there it is, 3 plus 4i. 3 plus 4i, sing it so you won't forget it. Okay, so it was to find the square root of 3 plus 4i. Boom. And our answers are as follows. and they wanted to express it in the form x plus iy or yi, you know, y. So the answers would be in this form. So first you write x. So let's see. The first value of x was 1. And when x was 1, we had a corresponding value of y being positive 2. So that'll be 1 plus 2i. Or our second value was when x was negative 1, you had the corresponding y value of negative 2i. Now, some students like to take this and they like to write it as follows. You can have a value of positive 1 taking place with the plus 2i. So you have, they'll have the positive going with the positive, and then they'll have the negative going on with the negative. So you can write it like that if you want, okay? So hopefully I didn't make any mistakes. I think it was good. Yeah, I think it was good. I don't think I made any mistakes and stuff. But if I do, just hit me up a comment down in the below, and I'll make changes in the description box. But you guys get the drift. So at the end of the day, now you're able to find how to add complex numbers, subtract, divide, what a complex conjugate is. And finally, I taught you guys an extra special move, how to find the square root of a complex number. So guys, I hope these videos were so helpful. Play them over and over. They're intended to replace like real life sessions in classrooms, so that if you are not close to a teacher, you don't have a teacher, you cannot afford extra lessons or tutors or private tutors or whatnot. Essentially, this is what goes on, you know, so you're not missing anything, and it's totally for free. And if you guys would like help with anything else, just feel free to message me and I'll try my best to see what I can do to help you guys. Okay, so much love, all the best, take care until I see you guys next time. Bye.